So at the end of, I think, part 3 of this video series, I promised to continue on the final tests. And so I'm getting to those now. This was the end of that video. Probably nobody gets to the end of my videos, but at the very end of that one, I did this exact test. This is a repeat of it, but I want to explain a little bit why I kind of wanted to highlight this. Just doing a record playback frequency response, and this showed some really nice high-end properties I kind of wanted to highlight. And so I'm just running through this again, repeating it. And then over on the right, I'll bring this up here in just a second. You see the 20 kilohertz there is the last vertical line on the right. And what I'm trying to highlight here and show with the cursor is the extended frequency response past that 20 kilohertz. You can see the frequency on the lower right, and then the amplitude of left and right channels. So here at 20 kilohertz, 22, 24, going up to 29, this deck is still laying down usable frequencies somewhere in between 29 and 31 kilohertz, which is the discrimination on this particular instrument. And so somewhere in between those two is where the frequency drops off. That's really good, especially for a cassette deck. Fairly common on real decks, but cassette decks don't generally get up this high. This makes a difference to me particularly because the decks that I test that I think sound the best all tend to have this characteristic. This one was kind of exceptional, so I wanted to make a point of it. Now, great frequency response, of course, means nothing without distortion numbers, because it can be biased to over-exaggerate the high frequencies, but it's always at the cost of distortion. And so now I'll run a high-end frequency test, and then at the end of each test on each channel will be a 0 dB distortion, third-order distortion test for a few seconds. And the specs on this, I believe they allow us 2%. And so there it is on the right channel, 1.1%. Left channel, 1.9. So still under that 2%. Left channel typically be a little bit higher distortion, especially on this tape I'm using, which is a newly open tape, but it's quite an old tape. And we'll just run it straight distortion test. And this deck, of course, has front panel controls on it, and so it gets dialed in for each recording manually. And I basically got it kind of at the peak of where it will be for this particular tape, and then my personal procedure is to just kind of over bias it a little bit until I'm happy with the sonics. This is a noise test I'm running. Again, same TDK SA tape. This is with Dolby off. Getting minus 60 and better dB. And then we'll try it with Dolby B. So I'm getting 69 and some change there. And then we'll try Dolby C. Right around 76. And this is all in spec and quite good. I'm happy with that. The numbers on the spec sheet are nice, but it's also important to see the actual results, not just advertised specs. Now this deck came to me in a partial state of rebuild, but the motor PCB was not finished, and it was unknown if it was actually operational or rebuildable or not. And so I think in the very first part of the first video, I recapped that motor and then tested the deck to see if it was functional, and it was found to be functional. And so rather than replacing that PCB, I recapped the original board and then tested it. And so I think, and then I tested it and I showed the wound flutter numbers, and then I took it back apart and finished it up and rebuilt the entire transport. And then now that that's done and it's the unit's been recapped and the power supply has been recapped, here are the results of the final wound flutter. And so I think it was around 0.05 or something like that when I first just put it together, just to evaluate it and see if it was able to be reused. So now that everything's done, these are the results that I'm getting before I ship this back to the owner. And I'll do this on beginning, middle, and end of the tape. Of course, I have to point out the dropouts here. Every time there's a dropout, it'll spike, but then it'll settle down and we'll get some real numbers on it. So this is down in the between the point 3 and 0.03 and 0.04 range. Get to a different spot in the tape, try it again. I'm obviously very happy with these results. Let me just reset that quickly. There we go. Okay, so maybe even a tad better at this point in the tape. I think I'm at the middle here. That looks really good. I think the spec on this deck is 0.04% is the advertised spec on it. Now lastly here, I'm just going to repack the tape a little bit and then give it one last test. I've gone back and forth quite a bit quite a while on this tape without ever really repacking it a little bit. I just want to do that and see if I can get even better than what I got on the last result. My goal here, as much as possible, is to better the factory spec, and it's possible because all these components, every part that goes in these decks and everything we buy really has tolerance, and if those tolerances can be locked down a little bit and tightened up, a lot of times we can get better performance than what the factory does, just doing nothing more than meeting those tolerances. So this isn't unusual that I can better the factory spec on it. It just takes time and effort, and it can be done. All right, let's see how it does here. Yeah, and that's what I thought. I thought I could get it in that 0-2 range. I've been through this a few times, and I know that I can generally get these down like that. They have good solid transport in them. All right, let's just make sure our speed is good before I ship it off. I know I like to generally run these in that 0.07 to 0.12 range fast, but this deck's going to a professional environment, and I'm going to get it right to 0 for him, and then he can make any adjustments he wants to from there. But I'll send this one off right at 0.00 on the speed. That's the pitch control going up and down. So there it is, just a short little video showing the final results, and I'm happy with how it turned out, and I hope my client is also. So thank you for watching, and tune in for more.